أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله. I welcome you back to our channel today. In the previous class, we explained the concept of projectile. We said in that class that a projectile motion is a two-dimensional motion. It has both vertical component and the horizontal component. And when analyzing the motion, we consider the two components separately. We do not join velocities for horizontal and vertical component in a single mathematical equation. This would be wrong. Another thing we said was that any object you throw into the sky and you allow it to move under the influence of gravity, that object is called a projectile. The path followed by the object in the sky, okay, we call that path its trajectory, okay. But we did not derive any equation, we only explained the concept. We also explained that the horizontal component of its velocity is constant throughout the motion, but the vertical component is influenced by gravity. The vertical velocity from the beginning, its direction is upward, 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 and it is reducing when it reaches the maximum height. When the object reaches its maximum height, the vertical velocity is 0. Now when it leaves the maximum height, it is now falling down. Then the vertical component reverses its direction. It is now downward in the direction of motion, and it is increasing. At the end, when it reaches the ground, it has both horizontal velocity and the vertical velocity. We can get the resultant of the two velocities. This is just a quick recap of what we learned in the previous class. In today's class, inshallah, we will derive the relevant formulae that we need for solving problems related to projectile motion. But before we begin, I want us to understand that the formulae we are going to derive today, they are applicable only when the angle of projection is given. Okay, when the angle of projection is given, we use those formulae. If they are not given, we are just told, for example, that an object is thrown vertically. When it is thrown vertically, we know that the angle is 90 degrees, so we don't have to resort to using those angles. Instead, we use the formulae that we know for motion under gravity. V is equal to u plus or minus gt, h equals ut plus or minus half gt squared, and v squared equals u squared plus or minus 2gh. They are also applicable for solving problems related to projectile, because if you throw an object, whether it's vertically or horizontally, from our understanding of the concept of projectile, any object you throw into the sky is a projectile. So if I throw an object, whether I say vertically or horizontally or whatever, it is a projectile. And for that, motion under gravity is also considered a projectile motion. But the one we are dealing with here is a more general form of the projectile motion, when the angle is between 0 and 90 degrees. Like you have angle 30 degrees, 45 degrees, 60 degrees, anything less than 90 degrees, then we consider the formulae. So to begin with, we now start with what we call time taken to reach the maximum height. Time taken to reach the maximum height, and this time is denoted by small letter t, meaning if you throw an object into the sky, how long will it take to reach the maximum height, the maximum possible vertical distance, okay, and is denoted by small letter t. and we will also get what we call time of flight. Okay, time of flight, and this time is the time taken by the projectile, is the time taken by the projectile to make the complete motion, okay, from the point of projection to the point of hitting the projection plane again. So let's see how we will get that. I'm going to draw the general case here, and then we explain what is happening here. Remember what we said: if the projectile is projected with an initial velocity u, it makes angle theta with the horizontal. Then it has vertical velocity. This vertical component of the velocity is u sub y and is given as u sine theta. It also has the horizontal component, and this horizontal component is written u sub x, and its magnitude is u cos theta. Now, because of the influence of gravity, it will not follow through this path. Gravity will make it bend, and then the motion will be like this, and it will hit the projection plane again. So our what we want to know is that when the projectile is in air, okay, when it is launched from here all the way to here, at this point it reaches its maximum height. Can you see this one? This is the maximum height. So when it is here, how long will it take it to reach here? That is our question. So to get that time, we start by using this formula that say v is equal to u. Since it is going up in the sky, our g is negative, so minus gt. We use this. Remember what I said, that it's also motion under gravity, so we are allowed to use the equations of uniformly accelerated motion. Now, I also pointed out that we don't combine two different velocities together. If you are using this equation, your final velocity and initial velocity must either be for the horizontal or for the vertical. Now, since it is going up, the velocity that makes it cover a vertical distance is a vertical velocity. So our v here should be v sub y for vertical velocity, and u here should be u sub y for vertical velocity. Now, at this maximum height, the v sub y is 0, because we said that this vertical velocity, as it is going up, the vertical velocity is decreasing, and at maximum height it is 0. So our v here is 0, is equal to then our u sub y. Look at our u sub y, u sine theta. So here this one becomes u sine theta minus g. This is gravitational acceleration, t, and this t is the time taken to reach this maximum height. From here we can take this to the other side. It is positive gt is equal to u sine theta. Then we divide both sides by g, divide both sides by g, g cancel g. So clearly we can see that our t is equal to u sine theta over g. This is the time taken by the projectile to reach its maximum height. Whenever you are asked to calculate the time taken to reach maximum height, this is the formula you need. Time this is time taken to reach maximum height. Maximum height. Okay, so I'm going to call this equation 1. This is our first equation. What if I want to get the time for the whole journey? I want to get the time taken for the whole journey, meaning the time taken to reach the maximum height, and then the time taken to move from maximum height to come back to the projection plane again. Then you remember this idea, okay, that the time taken to move from here to here is equal to the time taken to move from here to here, okay. So if you want to get the time of flight, okay, time of flight, This time of flight is denoted by capital T, and it is twice T. You double the time taken to reach the maximum height. When you do that, you see your time of flight will be um, 2, then your T is U sine theta over G, so U sine theta, I'm sorry, I don't have this, let me rewrite this. Your T is equal to 2T, and then T is U sine theta over G, so it's 2U sine theta divided by G. Now, this is the formula you need to calculate the time of flight. Now, this is equation 2. Now, we can also deduce this formula using another concept. Okay, we can deduce this formula using another concept. Let me show you that. Remember, I'm going to draw this again. Okay, is projected with an initial velocity u, and then here you have u sine theta as your u sub y, and then here you have the angle of projection theta, and then here you have u sub x, and this is u cos theta, and we have the trajectory here. Okay, so if I want to get the time taken to move all the way from here to here, then I will use this formula that says y is equal to ut minus half gt squared. This y is the vertical distance. Vertical at any point it is, you see, is y. This let's call this y1. Somewhere here it is y2. When it reaches the maximum height, we give a special name for this y, and is capital H for maximum height. Now, since this height is vertical, the velocity we will consider here is not horizontal velocity but vertical velocity. So this is u sub y. Another thing is that, remember, we put negative here because for it to get to have this y, it has to move upward, and when an object moves upward, the g is negative. G is considered negative. Now the our point here, the point we are trying to make here is that if it moves from here to here, the height is increasing and then it begins decreasing, and at this point when it hits the projection plane again, your y is 0 because there is no vertical distance here. So if there is no vertical distance at that point, then your y is 0, and this is equal to then here u sub y is u sine theta. We know that u sub y is u sine theta. You can see that here. And then the time here, this one is u sine theta, and the time here becomes the time of flight, capital T, because it is here already. It has completed the journey. So minus half, then we have g, and then time again is time of flight, capital T. Now I can multiply both sides by 2 if I to cancel this fraction. Every time will be multiplied by 2. 0 times 2 is 0. Then this one times 2 will be 2u capital T sine theta. Okay, then minus, if I multiply by 2, the 2 will cancel the 2 under here, and I will have g capital T. Okay, this one I will rewrite it in such a way that the 0 is here, and then I bring the right hand side to the left hand side. When I do that, I have 2ut sine theta minus gt is equal to 0. Okay, this one I can factorize t. Okay, there is square here. I can factorize t here, so I have t into 2u. If I remove t here, I have 2u sine theta minus g. The 2 here is double, so if I remove 1, I still have 1, is equal to 0. Okay, moving on. This one we remember our idea of quadratic equation. When we solve quadratic equation by factorization method, at the end we say either this first one, t is equal to 0, or what is in the bracket, 2u sine theta minus gt is equal to 0. So we continue and say, okay, t is equal to 0, or you see, we can take this one in the second equation, we can take this to the other side. So we have 2u sine theta is equal to gt, it becomes 0. T is equal to 0, or we can now divide both sides by g to make, in order to make t the subject of the formula in the second equation. When we do that, g cancel g here, and then we can see that our t is equal to what we have here, 2u sine theta over g. So clearly we have two results. T is equal to 0, and then t is also, which one is our time of flight? The explanation given by physicists is that this t is equal to 0 is here at the beginning here, just before you start timing, t is equal to 0. But after it has completed the journey, here you still have t is equal to 2u sine theta over g, and this is your time of flight. So again, we established that our capital T is 2u sine theta over g. This is our time of flight. Whenever you want to calculate the time of flight, this is the formula you need. Okay, another thing is the maximum height. How can I get the maximum height? Okay, another thing is the maximum height. What formula do I need to calculate the maximum height? Okay, maximum height, this one is denoted by capital T. Okay, I'm going to draw it again. Okay, I have this, is projected like this with initial velocity here at an angle theta, and the trajectory due to the influence of gravity is like this. Okay, my u sub x is u cos theta, my u sub y is u sine theta. Okay, now I want to get this maximum height. How can I get the maximum height? Remember the formula that gives you the vertical distance at any given time is y is equal to u sub y t minus half gt squared. Now at maximum height, your y is capital H, and this is equal to, then your u sub y is u sine theta as it is here, and then close bracket, this time should be time taken to reach the maximum height. Time taken to reach the maximum height, we got it here. You see time taken to reach the maximum height is u sine theta over g. So you put here u sine theta over g. This is your t. Then minus half g. Again, this t is time taken to reach the maximum height, so again u sine theta divided by g, and this time is squared, so we square this one. Now you simplify the expression on the right hand side. Okay, this is equal to, you have u and you have u here, so u by u is u squared, and then you have sine theta and sine theta. This is sine square theta. This sine square theta, when you multiply sine theta by another sine theta, okay, you can write it like this, sine theta square, but this one is simplified as sine square theta. Please, this one should be up, because if you bring it down, sine 2 theta, it has different meaning. The 2 should appear as a square. Okay, then I have sine square theta divided by g. then minus half g. Okay, this squared should extend to everything here, so I will have u squared and then sine squared theta divided by the g also squared. Moving on, this is equal to u squared sine squared theta over g minus, then g will cancel one of the g here, and then I have 2 times g, which is 2g, so the numerator will be u squared sine squared theta divided by 2 times g, 2g. I'll continue and say, okay, what I have here, what is the LCM of g and 2g? The LCM is 2g. And then I divide 2g by g cancel g, I have 2. 2 times this will be 2u squared sine squared theta minus, I take this minus here, then 2g divided by 2g is 1. 1 times this expression gives u squared sine squared theta. Okay, let me continue here. Okay, now how do I simplify this one? If you look at the expression here, this one 2 then this, and you look at this and this are the same. It's just like saying 2x minus x. 2x minus x will give you x, so 2u square sine square theta minus u square sine square theta will just be u square sine square theta. So your answer will be u square sine square theta divided by 2g divided by 2g. Hence whenever you want to get the maximum height, the maximum height is given by u square sine square theta divided by 2g. This is the formula we use to get the maximum height. Okay, this is the formula we use to get the maximum height, and I'm going to call this equation 3. This is our third equation. Is there any way we can get this formula? Is there any idea we can use to get this formula? The answer is yes. If this process is confusing, or you don't understand it, or is too difficult, there is another idea you can employ to use to get the maximum height. You see, I'm going to write O here. If you like, you can use this formula: v squared equals u squared minus 2gh. This one for motion under gravity. Since it is vertical motion that we are considering, our v must be vertical velocity. So at maximum height, remember, at maximum height I said vertical velocity is 0, so you put 0 here, is equal to, and then this u, I have to put y here, then this u we know is u sine theta for vertical velocity. Since it is squared, we square this one, minus 2g. At maximum height, this height has a new letter, a special letter, capital H. So from here I can take this to the other side, and I have 2gh equals, then you clear bracket here, you have u squared sine squared theta. Next, you divide both sides by 2g, divide both sides by 2g, divide both sides by 2g, and then here now 2g cancel 2g, and your h is equal to u squared sine squared theta divided by 2g. And you see, you have the formula again. This is same as what you have in equation 3. Let me bring it and you compare it. You see, h equals u squared sine squared theta over g. Look at it, h equals u squared sine squared theta over g. Okay, so this is how we obtain the formula for maximum height. Then we can move on to another important concept of a projectile, which is the maximum horizontal distance covered, which we have a name for it, and the name is range. The range of a projectile. This range is given the letter capital R. The range of a projectile, again, I have to draw this. I have to draw this one. Okay, this is initial velocity, angle theta, u sub x equals u cos theta. In this direction, In the vertical direction, we have u sub y, and this is u sine theta. Okay, then because of the influence of gravity, it will not move along a straight line, it will bend like this. Great. Now, if at any point, let's say at somewhere here, before it reaches the maximum height, it has a vertical velocity y. At the same time that it has this vertical velocity, vertical displacement y, then it has a corresponding horizontal displacement x. And how do I find this x? How do I find this x? Again, I will use this formula. S is equal to ut or h, since it is motion under gravity, is equal to ut minus half gt squared. So for here, since I am considering horizontal motion, my h should be x for the horizontal distance. And then again, remember, I am considering horizontal motion because my x is horizontal. Okay, so my u, I have two different velocities, u sub x, u sub y. When I'm considering horizontal motion, I will use u sub x. When I'm considering vertical motion, I will use u sub y. This is horizontal, so I go for is equal to, I go for u sub x. Okay, now this will now be t minus half gt squared. Okay, um remember again that this g, I said in the previous video that g, the direction for g is vertically downward. Okay, that is the direction for g. So it has no influence on horizontal motion. Anything horizontal, g is 0. And since I am considering horizontal motion, my g here should be 0. It has no influence on horizontal motion. And when g is 0, this second term vanishes, and I just have x is equal to ut, x is equal to u sub t, u sub x small t. So at any time I want to get the horizontal distance covered by a projectile, the horizontal distance is x and is given by horizontal component of the velocity multiplied by time taken to cover this distance x. Now, if I want to get the range, because the range is when it reaches here, and when it reaches here, it becomes range. It's the maximum possible horizontal distance you can have, okay, here. And now I should remember that when it reaches here, the time is no longer small t, my time is capital T, which is the time of flight, okay, is capital T. So let me rewrite this one again. I know x is equal to u sub x small t. Now when you have range, this x is maximum, it becomes r, and then you have your u sub x is u cos theta, okay, and then this your t becomes capital T, becomes the time of flight. So we continue and say, okay, we have u cos theta, and then this capital T, time of flight. We got the expression for time of flight. Where is it? You need this expression now. You see, it says T is equal to 2u sine theta over g. So you write it 2u sine theta divided by g. Then you continue. This is equal to u times u is u squared. Then you open bracket. There is something we want to achieve here. Then you write this 2, you bring sine theta, and then you bring cos theta, and then you close bracket divided by g. Now we have to simplify the expression in bracket. In mathematics, there is what they call trigonometric identities. There is two expressions that are identical. When two expressions are identical, then we say they are they are identities. You can have them in algebra, you can also have them in trigonometry. Like tan theta, we say is equal to sine theta divided by cos theta. For any value of theta, they are the same. Tan theta is always sine theta over cos theta. Then these two sine theta cos theta is identical to 2 sine theta cos theta is identical to what they call sine 2 theta from mathematics. So instead of this long expression 2 sine theta cos theta, you can identically use sine 2 theta. When you bring that here, you have u squared sine sine 2 theta, okay, from trigonometric identities. What is in the bracket is identical to this one divided by g here. Okay, so this now gives us the expression for the range. So we can conclude that our range is equal to u square sine 2 theta over g. This is the expression for the range, and this is our equation 4. Whenever they ask you to get range, then this is the formula you need to calculate the range. Now, for range in particular, for range, you can have a maximum range. There is a formula you need to get the maximum possible range you can have for a projectile, okay, because range can be minimum as well, it can be maximum. So we want to know the angle. There is one special angle for which this range is maximum. How do we get that angle? We should first recognize that this expression sine 2 theta, okay, the maximum value for it is 1. So it is when this expression is maximum that you can have maximum range. Okay, it is when this expression is maximum that we can have maximum range. So we want to know what will be the angle theta for which this is 1. But before we do that, remember that if this is 1, okay, then your r, this r here becomes maximum, r maximum, which is maximum range, and u square times 1 is just u square divided by g. So this one, this is the formula you need to get maximum range. If they just say range, use this formula. But if they say what will be the maximum range, ignore sine 2 theta and use r sub max equals u squared divided by g. This will give you maximum range, and this is equation 5. But the question that remains unanswered is, for what angle can we get this maximum range? We will find that out. We know that our sine 2 theta is equal to 1. When this happens, we have maximum range. So what we will do now is to say 2 theta is equal to sine inverse of 1, meaning we are looking for an angle for which sine is 1. The sine of that angle is 1. So how do we do that? We bring our calculator and we press, for the sine inverse, we press shift, this one shift, and then you press sine inverse will appear. You see sine inverse appear, then you now press your 1, okay, press 1. If you press 1, press equality sign, and when you do that, you see sine inverse 1, the angle given is 90 degrees. So it means 2 theta is equal to 90 degrees. Next, you divide both sides by 2, divide both sides by 2, divide both sides by 2, 2 cancel 2, and then you now have theta is equal to 90 divided by 2, 45 degrees. It means that when your angle of projection is 45 degrees, you can have maximum range. We can conclude and say when the angle of projection is 45 degrees, the range capital R is maximum. The range is maximum. Please don't forget that. Range is maximum when the angle of projection is 45 degrees. Now, as quickly as possible, let us summarize all the formula we need. The first formula we derived was for time taken to to reach the maximum height, and that time was small t is equal to u sine theta over g. This is the first formula you need for time to reach maximum height. Maximum height. Okay. Now the second one is the time of flight, capital T, and this one is twice this. You say 2u sine theta over g, and we call this equation 2, and this is for time of flight. Next, after these two times, then we got the expression for the maximum height, and we got that this maximum height h is equal to u squared sine squared theta divided by 2g, and this is equation 3. This is for maximum height, when you want to get the maximum height. Then if you want to get the range of a projectile, we just obtained the formula for that. It says the range is equal to u squared sine 2 theta over g, and this is for the range of a projectile. Again, if you want to get maximum range, r sub max, we say you ignore this sine 2 theta, and you have u squared divided by g, and this is equation 5, and this is for maximum range. Now these 5 equations are very important, very important when you are evaluating or when you are solving problems related to projectile motion. Also, don't forget the remaining ones, such as u sub y is equal to u sine theta, and then u sub x is equal to u cos theta. Any vertical displacement is given by u sub yt minus half gt squared, and any horizontal displacement x is given by u sub x multiplied by t, and for this one particularly we say that g is equal to 0. G has no influence on the horizontal motion. So with this one, I think we have solved almost every problem related to the concept of projectile. The only thing is that we have to get mathematical. So the next video will be problems with their solutions, and we will use both this formula, and also remember we will also use the motion under gravity formula. I hope this video helps you a lot in understanding the concept of projectile. May Allah put barakah in your learning. Assalamu alaikum wa rahmatullah.